All right, did we finish this problem? All right, we have a table of values here. Give me the best approximation of the x values. So 3.2. So look at our table. What's the closest x value to 3.2? 3. So we're going to use this. Oh, okay. Hold on. We're going to use this row right here to answer the question. So this is where we're going to first write an equation of a tangent line. So look at our x and y. That would be y plus 4 equals, what's the slope? 1/2 times x minus 3. That's your first step. Write the equation of the tangent line. Do we remember what the next step is? Plug in this 3.2 in for x. So that would be 1/2 times 3.2 minus 3. And I'm also solving for y. So I could go ahead and write y equals and subtract the 4 on the end. You do not need to simplify this. You can just leave it like that. So this is our approximation right here. It says, is it an over or under approximation? What tells us? The second derivative, the concavity. So is it concave up or down? Down. So that means the tangent line is above the curve. So it's an over approximation. It doesn't say justify, but if it said justify, you would write f double prime of 3 is less than 0. So you're using the value from the table. This is less than 0. Okay, f of 8.7, what number do we have closest to 8.7? 9. So I'm going to use this row for this one. So write my equation of my tangent line. Y minus 1 equals 3 times x minus 9. Plug in 8.7 for x, solve for y. So y equals 3 times 8.7 minus 9 plus 1. There you go. There's your approximation. Is this one an over or under approximation? Under, we have concave up, so the tangent line is below the curve, so it's an under approximation. And I would say f double prime of 9 is greater than 0. Okay, this next question is straight from an old AP exam. This is how it will come up a lot of times. It could be like the table like we just did, or where they just give you the little pieces of information. So it says, what is the value of the approximation of f of 1.9 using the line tangent to the graph? So they're saying use a tangent line. So I know I need to make an equation of a tangent line. Let's see, y minus 1 equals 4 times x minus 2. So I use the point, and I use the slope of the first derivative at x equals 2. And we're plugging in 1.9. Okay, in this case, I am going to have to simplify because it's a multiple choice question. So let's see. This is negative 0.1 times 4 plus 1. So negative 0.4 plus 1 is 0.6. There we go. And it will probably be like one multiple choice question on the AP exam. Okay. All right. Today we are going to learn a rule. It's called L'Hopital's rule. L'Hopital, that's the name of a guy. I can show you his picture. If I can find a powdered wig, maybe I'll dress up as him one day. But he came up with this rule, and it has to do with limits. So we are going to take a flashback to limits today. If you took a look at your homework, it's a bunch of limits problems. So this is kind of good to bring it all back because that was quite a long time ago. We are going to use all of our strategies for limits. So you're going to learn this new rule today, but on your homework, you don't have to use this rule for every single problem. In fact, we'll talk about like when it's faster to use whichever strategy. You can use this rule if you get an indeterminate form of 0 over 0 or infinity over infinity. And here it is. By the way, we have test corrections tomorrow. We're going to learn some theorems on Wednesday and Thursday, quiz on Friday. If you are out Friday, your test grade will just go in for your quiz grade. Okay, so what this says is if we have a fraction and we get 0 over 0 or infinity over infinity when we plug in, you can take the derivative of the top and put it over the derivative of the bottom. So we didn't learn this back in Unit 1 because you didn't know how to do derivatives. So a lot of times L'Hopital's rule comes up on multiple choice questions. Is your work graded on multiple choice questions? No, so you can just quickly apply the rule and do it if it comes up on multiple choice. I'd say once every 5 or 6 years, it'll come up in a free response section. If it comes up on free response question, there's something you have to write first before you can apply the rule. So it's a little bit tedious because you got a little bit of writing to do. So sometimes it's not the fastest method. So we're going to do 2 problems. We're going to do it both ways. I'm going to show you what we would have done back in Unit 1. We'll talk about what you do for L'Hopital's rule, and we'll decide which one was faster. Because I think for every problem that you do, if there's more than one way to do it, you always want to choose the fastest way, right? Save yourself some time. What is our very first strategy for doing any limit? Plug and chug. Okay, so if I plug in a 1, what do I get? 0 over 0. Okay, so if you remember back from Unit 1, when we get 0 over 0, that means we need to do something else. So look at this problem. What do you think we should do? Yeah, why don't we factor it? Okay, so limit as x approaches 1 of x times x minus 1 over x minus 1, x minus 1. Okay, what do we notice? Cancel the x minus 1s. So now I just have x over x plus 1. Can we plug in 1 now and get an answer? Yes, and what do we get? 1/2. This is always a valid method still. I mean, I don't think that was too bad. I don't think that was too long to do. Here's what you have to do if you're going to use L'Hopital's rule. We have to first state that the numerator's limit and the denominator's limit both equal 0 separately. This is the part that is a little bit annoying. Limit as x approaches 1 of x squared minus x equals 0. Limit as x approaches 1 of x squared minus 1 equals 0. So you have to say that first. Then you can apply the rule. Okay, so here's what that looks like. I'm going to rewrite limit as x approaches 1. What is the derivative of x squared minus x? Minus 1. Okay, and what's the derivative of the bottom? 2x. Okay, now when we plug in 1, what do we get? 1/2. Yeah. Okay, so either method works. Which one do you think was faster? I feel like they're like almost the same. I don't know. If you're doing it in your head, 2x minus 1 over 2x, I think that part would be faster. I don't know. This wasn't that bad. But writing that part out is a little bit annoying. So it's up to you.
Like longer enough.
Yes. Okay, so whichever way you want. Okay, here, let's try another one. Can you see what this limit is approaching? Limit as x approaches infinity. We treat this one a little bit differently. So infinite limits, you're just thinking about the end behavior of the function. This is what type of function? A rational function. So we got to think about our horizontal asymptote rules. So is this top heavy, bottom heavy, or equal? Equal. So what does that mean it's approaching? 1/2. Just going to rewrite the problem over here. So here's the work you would have to do the old way. There is no work. You can just write the answer. So I would definitely choose this method. If I know my horizontal asymptote rule is just write the answer. You don't have to show any work for this. L'Hopital's rule could be helpful if you forgot your horizontal asymptote rules. Okay, so let's show what that would look like. So first, we have to show what the limit of the numerator and denominator are separately. So limit as x approaches infinity of x squared minus 1. What is that? What is it approaching as we go to infinity? infinity. Limit as x approaches infinity of 2x squared plus 1. What is that one approaching? Infinity. Okay, so infinity over infinity is another case where we can use L'Hopital's rule. So let's do it. Limit as x approaches infinity of, what's the derivative of the top? 2x. The derivative of the bottom? 4x. Oh, look, the x's cancel. What do we have? 1/2. So yeah, this was more writing, but this is kind of nice. Like, what if you're like, I don't remember my horizontal asymptote rules? You have this, you can fall back on now.
Wait, I'm confused. How did you go from the infinities to the 2x?
This is just saying I can use L'Hopital's rule because I got infinity over infinity. This one is where you do the derivative of the top over the derivative of the bottom. Okay? All right, so now we're going to do probably 4 different types of problems, and we are just going to choose whatever method we think will be fastest. We're not going to do it 2 different ways every time. Our first strategy is always to do what? Plug it in. What is the log of 1? 0. Yes, you need to know that. That is going to come up on the AP exam. Log of 1 is 0. And then on the bottom, we get 0. Okay, so we can use L'Hopital's rule. If you can think of another strategy that might be faster, let me know. Yeah, I don't know what to do with this one. So this is one where I would definitely want to use L'Hopital's rule. So let's go ahead and state what we need to state first. Limit as x approaches 1 of log of x equals 0. Limit as x approaches 1 of x minus 1 equals 0. Okay, now we can do L'Hopital's rule. So now I'm going to rewrite my limit notation. What's the derivative of natural log of x? 1 over x. What's the derivative of x minus 1? 1. Ooh, and now what do we get? We just get, if we plug in 1, 1. This is the type of situation where you'd want to use L'Hopital's rule, because like I don't really know how to do it any other way. Okay, here's another one. All right, this one is a limit as x approaches infinity. So we're thinking end behavior. So if we can figure out if this is top heavy, bottom heavy, or equal, we don't have to do any work. Anyone want to take a guess? We have an exponential on the top and an x squared on the bottom. Which do you think will grow faster or quicker? The exponential. So it is top heavy. So what does that mean it's approaching? It's a slant asymptote, so what are we going to? Positive infinity. So it is infinity. Let's say, because some of you guys were like, I don't know if this is top heavy, bottom heavy, or equal. Well, let's use L'Hopital's rule. So by the way, you could write equals infinity and be done. But if you're like, I don't know, let's see what happens when we apply L'Hopital's rule. E to the x equals infinity. X squared equals infinity. Okay, so now we can do L'Hopital's rule. What will we have on the top? E to the x. What will we have on the bottom? 2x. And you tell now that it's top heavy. Yeah. Guess what? You could even keep doing L'Hopital's rule again. What would it be the next time we did it? E to the x over 2. Okay, now it's like, okay, for sure it's top heavy. So you can continue doing L'Hopital's rule multiple times. And it really helps on these ones where you're trying to figure out if it's top heavy, bottom heavy, or equal. It becomes really evident at a certain point. I think we'll do 2 more. Okay, so let's plug in pi in our heads to see what we would get. What's the sign of pi? 0 and 1 minus cosine of pi. 0. Okay. Do we have any strategies? Or should we use L'Hopital's rule? Cosine of pi. Wait. Oh, wait, is this a plug and chug?
Yeah.
Well, we totally did it wrong in first period. I think I just assumed it was gonna be 0/0. Cosine of pi is -1, so 1
So it's 0.
plus 1, so it's 0/2. Okay, so let's not do L'Hopital's rule, it wouldn't even work here. So what is it?
Cool.
So this is a good reminder, by the way, that on your homework, don't just start doing L'Hopital's rule for everything. You have to, L'Hopital's rule only applies if you get 0/0 or infinity/infinity. Okay, this will be the last one then. Okay, let's plug and chug. Tangent of 0 is what? 0. Sine of 0. Okay, so this is one we could use L'Hopital's rule. Is there any other strategy that might work? We could make this sine of 5x over cosine of 5x. We could make this, I mean, that's sine. However, they have different arguments. So we actually can't simplify, but I like what you're thinking. I think we should do L'Hopital's rule. You can do 5x. Okay, now we can do L'Hopital's rule. Limit of x approaches 0 of, what is the derivative of tangent of 5x? Secant squared 5x times 5. And derivative of sine of 3x. Cosine 3x times 3. Okay, now let's plug in. The secant of 0. What is that? Nope. 1. Okay, so that's always 1 times 5. And then cosine of 0, that's 1 times 30, so 5/3. Okay, so that's L'Hopital's rule. The answer key is up here for the next worksheet. Remember, you can use any strategy you want to. So let's see, on this answer key, see how many times did I use L'Hopital's rule? 1, 2, 3, 4, 5, 6, 7, 8, 9. I use L'Hopital's rule 9 times out of 15. That doesn't mean you have to use it 9 times, but just to let you know, like, don't just do it for everything.